Welcome back to our channel. Today we are going to talk about three important concepts in RL, that is value iteration, asynchronous dynamic programming, and generalized policy iteration. Um, let's discuss about in detail more about them. So, what is value iteration? Value iteration is a method that combines policy evaluation and policy improvement into one step. So instead of evaluating the entire policy at once, we only evaluate it for one step. So this can improve the policy based on the evaluation. So updated rule for value evaluation is this E of k plus 1 argmax summation of p into the next state comma r transition probability of between r and s comma a and r plus discount factor v of k into v of k into next state. So this is the formula you need to remember obviously. So this means that we update the value function for each state based on the maximum expected reward we can get by taking an action in the state. For example, let's say we are playing a game where we can move left or right. The value function would tell us that expected return for each state, given that we are following an optimal policy. So by updating the value function using the update rule, we can come to the optimal value function. Asynchronous dynamic programming. Asynchronous dynamic programming is like a method that allows us to update the value functions in real time without having to evaluate the entire policy at once. So instead of doing full sweeps of state space, uh, we can update the value functions as we experience the new states or the actions. So this can be especially useful in the situations where a state space is very large or where we don't have access to the entire state space. It is useful in that situations. So for example, let's take another example. When we are playing a game, we can move left, right, but we don't know the entire state space. We can use this asynchronous dynamic programming to update the value functions as we experience the new states and actions. And then when we discuss about generalized policy iteration is nothing but a framework that combines policy evaluation and policy improvement into one process. The key idea is that we can let policy evaluation and policy improvement interact with each other regardless of the granularity of the updates. So this means that we can update the policy and value function at the same time. So up to we are updating these policy and value functions at the same time up to still the convergence to the optimal policy. So for example, let's say we are playing a game where we can move left or right again, and then we can use this generalized policy iteration to update the policy and value functions at the same time and still converge to the optimal policy. So value iteration, this is the diagram generalized policy iteration leading to optimality. We value function and the value function and the policy pi, and this is where these both values are equal, and these are the v star and vi values. By choosing the greedy actions, it leads to v star and v pi. So this is the diagram of generalized policy iteration leading to optimality. And there are some few more concepts like uh, it's the ending topic might be. So these value iteration and DP and generalized policy iteration are also important concepts in RL. So at last, value iteration combines policy, value evaluation, and policy improvements into one step, and it also updates the value functions in the real time. So, and next we'll be discussing some summary points in all about the function. So policy evaluation is the iterative computation of a value function for a given policy. Uh, this is the some key points like policy evaluation, policy improvement by combining those values, and the main these few points are like the summary means definitions of the each concept. You can revise them by taking a screenshot or writing in your notes, and then that's it for this video. Uh, if you have any queries, please leave them in the comment section below. Don't forget to like and subscribe for more videos on RL. Thank you.